So identify 5 random phenomena that occur in your life. Well, a whole variety of things possible. I've written some down here. You can read them. Question 2 involves random phenomena can't be predicted in the short term, but can have regular patterns in the long term. Well, so let's see if we can see which pattern would not be random phenomena of coin tossing. So in A, obviously here, this is not a random phenomenon of coin tossing because they're all tails. In B, you got 2 heads, a tail, 2 heads, 2 tails, a bunch of heads, a tail. So B actually looks pretty random to me. What about C? Well, C has a pattern HT, 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 HT. It's not varying, so C is not an example of a random phenomenon. What about D? Well, in D, you've got head, 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 and then you also have tail, 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 tail. So D is also not an example of a random phenomenon because it's a repeating pattern. We have a repeating pattern in A, we have a repeating pattern in C, and we have a repeating pattern in D. So B is really the only example of a random phenomenon. So there's a class experiment. Students flip a coin 50 times. So they got some results in a table, 20 students. And then what we're asked to do is, since students have been flipping these coins, we're asked to figure out the proportion of heads depending on the number of flips. So what we're asked to do is to complete this table where, say here's student number 1 does 50 flips, and they get 27 heads. So 27 divided by 50, 27 divided by 50 equals 0.540. And that's where that number comes from. And now we're going to add in the next student's flips. They flip the coin 50 times. And after flipping their coins, the total number of heads now is 54. So 54 divided by 100 also is 0.540. Okay, now we can do the next one. Well, the total number of heads flipped after 150 flips in total is 81. So you go 81 over 150, and you get a ratio. Now, how did I get 54 is the question, and how did I get 81? Well, I'm going to go look at the table, and if I look at the table, student number 2 had 27 flips, student number 3 had 27 flips. So the first student had 27 flips to give a proportion of 0.54. Student number 2 had also 27 flips. 27 plus 27 is 54. Again, that's how we've calculated proportion. Student number 3 also had 27 flips. So each of these students all had 27 flips. So the next student, what they would have is student number 4 has got 28 heads. So 28 heads, 28 plus 81 is 109. So that'd be 109 over 200. Well, let's just calculate those values. So this is student number 1. Student number 1 ended up with a ratio of 0.540. Student number 2 also had 27 heads. The ratio stayed the same, 0.540. Student number 3 also had 27 heads. The ratio stays the same as 0.540. Student number 4 had 28 heads. Changed the ratio slightly. Well, you would think that this kind of calculation would be best done on something like an Excel spreadsheet. And that's what I have done. So here's the spreadsheet for the 20 students with a total of 1,000 coin flips. And you can see how the proportion has changed and is approaching 0.5, which is what you would expect if indeed the coin flipping is a random phenomenon, because you've got a 50% chance of heads and you've got a 50% chance of tails. The way I did the calculations on the spreadsheet, I I had a column for the number of heads for each student, and then I created a column with a running total of heads. So, for example, here in this column, I took the value that was in column C4, and I added the value from the previous running total. And I just copied that down the column. Then for the proportions, what I did was I took the value that was the running total and I divided it by the number of flips. So I generate some data where I have the proportions, and I just have set it up with another column of number of flips so I can make my graph, which I'm going to show you now. So here's the class result for the coin toss. We started out with a ratio of 0.540, and then ultimately after 1,000 tosses, we ended up with a ratio of 0.50 something or other, 0.0501, I think. And you can see that after a large number of tosses, things are starting to level out and that we are seeing what we would expect for something that had equal probability, a probability of 0.5 for heads. In other words, it's 50-50. 50% chance you're going to get heads, 50% chance you're going to get tails. Okay, so now we're going to assess probabilities for some outcomes. So Alex is in a class of 20 students. The instructor selects 3 out of 3 students to put homework on the board. Okay, to make the selection random, the instructor places the names of the students in a container and then asks the student to draw 3 names. So what are the chances that 3 of the 20 students will be called? Well, 3 out of 20 is less than a third, so the probability is low that Alex is going to be called in this situation. Okay, it's cloudy, quite humid and warm. Temperature is going to drop. Well, turns out that when it's very humid and the temperature drops, the atmosphere can't hold its moisture very well, so the moisture will condense out and become rain. So the chances of rain are high. Okay, next. After shuffling a standard deck of cards, you draw a card. Assess the chances of drawing an ace. Now, I understand that some of you are not familiar with cards, depending on your background. So a little bit of information. A card deck has a total of 52 cards. There are 4 suits in a card deck. You have hearts, diamonds, spades, and clubs. So how many of each suit are there? There's a total of 52 cards. 52 divided by 4 is 13. So in each deck of cards, there are 13 hearts, 13 hearts, 13 diamonds, 13 spades, 13 clubs. Now, what this means is in a deck of cards, for something like a number 2, there are 4 different 2s. There's a 2 of hearts, a 2 of spades, a 2 of diamonds, or a 2 of clubs. In a similar way, there are 4 aces, an ace of hearts, an ace of diamonds, an ace of spades, an ace of clubs. This becomes important because we're going to be dealing with probability and cards later in the course. So what's the probability of drawing an ace? Well, the probability of drawing an ace is 1 in 13. This is the probability of drawing an ace. Another way of saying this is that there are a total of 4 aces in the deck. And a total of 52 cards. So the probability of drawing an ace is 4 out of 52, which if you reduce the fraction is 1 in 13. All right, so without putting the first card back in the deck, you reshuffle the deck and then you draw a second card. What are the chances of drawing a red card? So here's the thing. Red cards are hearts or diamonds. Black cards are spades or clubs. let's say that the first card that you draw happened to be black, a black card. Well, what does that mean? Well, since originally in the deck there were 13 spades and 13 clubs, 13 hearts, 13 diamonds. If you draw a black card, what does that mean? Well, it means that the total number of red cards to start with was 26, total number of black cards to start with 26. So if you've drawn a black card with that first card, that means there's only 25 black cards left in the deck, but there's still 26 red cards. So what are the chances of drawing a red card? Well, the chances of drawing a red card, if the first card drawn is black, is there are still 26 red cards in the deck, but there's only 51 cards total left in the deck. So the probability of drawing a red card if the first card drawn was black is 26 out of 51. So 26 divided by 51 is 0.5098, or a 50.98% probability of drawing a red card if the first card drawn is black. So what if the first card drawn is red? Well, if the first card drawn is red, that means then that there are only 25 red cards left in the deck. So if the first card drawn is red, then the probability of the next card drawn red is as follows. You only have 25 red cards left in the deck, and in total there are only 51 cards left because you've already removed one of them. So then the probability is 0.4902, or 49.02% is the probability of drawing a red card if the first card drawn is red. So in the video that I want you to watch at the very start of this unit, it's an excerpt taken from a movie called Run Lola Run, which takes place in Germany. And so the roulette that the woman is playing is European roulette. And so in European roulette, there are a total of 37 numbers. The numbers start at 0 and go to 36. So like 0, 1, 2, 3, 4, all the way up to 36. So if she put her bet on number 20 and she won on the number 20, well, what's the probability of that happening? Well, there are 37 numbers total in the European roulette wheel. So 1 out of 37 would be the probability that she would win if she bet just on the number 20. What does that work out to in terms of a percentage? 0.0270, or a 2.70% chance of winning. So what are the odds for that? Well, the odds of her winning just once by betting on the number 20, 37 to 1. You take the probability, 0.0270, and you divide that into 1, and that creates a whole number ratio of 37 to 1. So those are the odds of her winning just once. Now, what we're going to find out in the next unit is, well, what's the probability of her winning 3 times in a row?